Hey guys! So today we're gonna start a new project. Yes, a new project. And now we start new projects because yeah, why have one or two when you can have multiple ones? Yeah, anyways, so this is a project that I have been working on background for a while now. And everything started when I purchased this multimeter. Now go show you. So this is a Philips PM2534. It's a 6.5 digits multimeter. It's a pretty decent multimeter, and I got for fairly cheap, less than 100 euros on eBay. And for an instrument of this class, it's a very good deal. If you check nowadays on eBay, they're gonna be more than 200 euros for the units. And one of the reasons that I think I got for a good price like this is because the display it's leaking. So you can see that there's this dark spot. So this is basically the LCD layer leaking and getting contaminating with the atmosphere. So the crystals are not polarizing correctly, let's put it this way. And the instrument works fine, all the functions are working fine, but there is this LCD problem that was annoying me since the beginning. And the first time that I opened this device, I already noticed that the front panel here, the plastic is very cracky, and so it basically broke most of the tabs and part of the inner insert here on the metal case. It broke and fell apart on my hand. So it's very dry, the material. So yeah, so because of that, I decided to do something about it. First, I was thinking to custom design a new LCD exactly with these specs and send it to China to manufacture a bunch of them, because I saw people on EV blog with the same problem. So I thought, oh, maybe I'm gonna design a custom LCD and make it like stock and have an alternative for replacement. But then I thought, no, let's improve and go to the next level. Since it's a very nice device, let's make it better in multiple ways. So yeah, so what I decide to do is to entirely replace this this front panel with a 3D printed version. So initially I thought about to use just the same design, the same original design. So I made this 3D printer model here with FDM printer to replicate exactly the original design, to use the same board and to go with this LCD replacement approach. But then I changed my mind. I wasn't happy because I think there's a few things that I don't like. First, I don't like the way that they did the connection on this multimeter. First, there is this probe connection here. There is that same connector used on MIDI instruments. The MIDI port, so it's basically the same connector. I forgot the name now. And if you wanna do, for example, forwarding resistance measurements, you need to use that connector with a special probe. I don't have that probe, and I don't wanna have just a special cable for that. So I wanted to wire up that port to banana plugs, so I can have the forwarding measurements as I'm gonna have for my LCR meter, for example, so I can use the same cabling for different instruments. Second, I'm gonna replace this original LCD with an OLED display. It's gonna give me a way nicer look and feel, and better visibility as well. And there are a few more things that I'm gonna show you. Let's go to the bench, because I already have more or less the final version. How is gonna be this? This is not the final version, and I wanna show you in the bench things that I changed. So here we have the front panel. I removed it from the instrument, and here was the first prototype that I made. So I was just planning to remove the label here and to put here, or to look like original. So this is not gonna be used anymore. What I came up is with this new layout. And first of all, this have been printed with SLA, and I need to give a big thank you to Marco Heps, because he printed this for me. I'm gonna be linking here down when his video is ready, so you can see the process of him printing this part for me. This is not the final part. You can see that there's a crack here, so this was just a test print to check the fittings, all the measurements. You can see actually there's a defect here, because he printed like this way, and here was the tip, so for some reason the resin didn't stick here. It's a bummer, but yeah, it's just a test part. There is a bunch of improvements here compared with the new ones that I want to go through with you. First, you can see that we have a dramatic change in terms of the connections here. So I want to go through with you with the differences. As you can see, in the original, we had two wire connection here, so ground and voltage and resistance, and here we had ground and current measurement. Okay, and we have guard as well, and a switch to connect the earth or zero with the guard, and the old probe to measure for wiring resistance, and to measure temperature with PT100. So it's a pretty decent instrument, 6.5 digits, pretty good. What I did here, I basically eliminate the probe, and now I have here the standard 4-wire connection. So the wiring that are gonna be coming from the probe here are gonna be allocated here. So I'm gonna have the sensor terminals here. So I'm gonna keep the force terminals here as the original ones, and then adding the sense terminals here, so are gonna look like the newest Keithley or Agilent, Keysight, whatever instrument. So I'm gonna have the same standard spacing, so we can use that joining posts, adapters, and here I moved the current measurement to the side. I relocate the guard here, and this one you can see that there's a slot here, and this is something that I came afterwards, because why not? So this is gonna be a port for a triaxial connector. This instrument didn't have an original triaxial connection, but well, I have spare connectors here, so I decided, oh, why not? Let's put a triaxial connection here as well. So yeah, so basically you're gonna have, I am gonna have all the connection options that I could want to use. You can see here that I have one of the new banana sockets. It's a nice Pomona, something like this. It's a nice gold plated connection, so yeah, I'm never gonna need to replace this connector anymore. Also, the buttons are gonna be different. If you are using different functions, or are you setting for example speed, acquisition speed, you're gonna have a small indicator here on the lower side of the LCD to specify which function you are using. So based on the HP LCR meter that I'm working on, and we have this nice LEDs on the buttons, I decided to do something inspired on these buttons. Actually, I'm copying the design of these buttons. I like a lot the HP designing of their old instruments. And what I'm gonna do, I'm gonna be replicating that design. So I already made the new front panel with the same HP design in terms of border, in terms of aspect ratio, to look very much like the HP. And of course, I'm gonna be making a new stick here. So the buttons, they're gonna be translucent. So what I'm gonna be using is switches with back LEDs, and I'm gonna be placing RGB LEDs here. Now you can be starting laughing and say, oh, everything is RGB, but yeah, I'm not gonna do like fancy stuff like gaming keyboards RGB. I'm gonna be using this LEDs to actually specify the function that I'm active right now. So we have many functions here, and actually when you, for example, you can go in sub menus here to select thing. So when I am in sub functions in the buttons, I want to change the colors as well to identify which function on the button I am active at that moment. The same time that is gonna be looking like an old HP instrument, is gonna have this more modern look and feel with like the back illuminated buttons. So I think it's gonna be gorgeous, the result. Since I'm gonna be making a new PCB, and in our next video I'm gonna go through with you guys on Altium with the new PCB project that I'm designing, already making some mechanical changes. So first of all, the original instrument had these tabs, these plastic tabs that used to hold the original PCB, and those cracked. So it was the first thing that cracked when I was trying to remove this this front panel from the instrument. And now I'm gonna be replacing with threads and screws here. So I'm gonna have a much stronger holding point for the PCB, and it's gonna be way easier to remove. I added the tabs, and I'm gonna be threading these tabs as well, and I'm gonna create this I'm gonna drill holes on the back of the instrument, and I'm gonna using screws here. So this is gonna give a much stronger holding for the instruments. Here on the upper side, there is some strips, some plastic strips that hold here, and those are fine. So I draw here the mounting point for this plastic strip, so they're gonna grip here. So on the top side, I don't need to do the tabs, because I could do, but then I would have screws on the top side, and I don't want that. So I'm gonna be using the original holding mechanism to don't change anything on the top side. Okay, so guys, so this is the plans for this multimeter, and yeah, so I'm very excited to see the results, and I wanna thank you, Marco, again, because he's printing to me, and this is just being possible because he has a very nice printer that he's gonna be showing you guys on his video, and yeah, so we're gonna have a fantastic part. This is a sample kit from Snaptron. And the reason that I'm showing you is because I'm gonna be using their metal domes as switches for this multimeter. And this is a very nice kit, and they were very receptive and very amazed with their customer service, so I just requested on their website the sample kit. They just sent me an email asking, do you need a specific part? Yeah, so I sent 2 of the domes that I was interested. One of them actually it's already here on the sample kit. This is the BL10280. Is this one here is a 10 millimeter radius dome with the hole here, and this hole is what's gonna be allowing me to place the LEDs in the back side of the PCB, and so we're gonna have illuminated buttons. So I'm very happy with this kit, and they also send me additional domes for the ones that I requested. So they sent me 2 additional ones. So yeah, this is a pretty nice sample kit, and now I already have all the domes that I need to populate this front board. They also send me the stickers here to hold the domes. So yeah, I just wanna say thank you to Snaptron, and guys, if you need metal dome, go to their website and check on the sample kits. If you need a special one that doesn't come on the general kit, yeah, you can just ask them for a specific part number, and they are gonna send you this nice small boxes with the domes do you need. I created a Patreon a while ago, and I wanted to have something, you know, before I start saying, subscribe to help me on Patreon, I like to give something back, you know. So from now, all the projects that I'm gonna be creating on this channel, I'm gonna be releasing for my patrons. So you're gonna have access to the repositories, their private repositories. So all my patrons are gonna have access, for example, to the PCB layouts of this instrument, the CAD designing. So I'm gonna be releasing all the parts to my patrons. So if you wanna support me, yes, you're gonna have access to exclusive material, and I think this are gonna be like hours of work. I already worked hours designing this instrument, for example. So if you wanna buy on eBay an instrument like this and wanna do these mods on your own, you're gonna be able. And yeah, so this is it, guys. So thank you for watching this video. If you like this content, please subscribe. This is very important to me, and give you a thumbs up and leave your comments if you have any suggestion, especially about this project. If you have anything cool future that you would like to see on this instrument, there is time yet. Maybe if you have any cool suggestions, I'm open to hear. So see you next video.